Hey everybody, it's time to review U-Substitution. You're going to see integrals on the front and back of this review sheet that most of which require some sort of substitution to be able to integrate. I think there's one or two, and the directions will note that you actually don't need U-Substitution to solve. You're just practicing with your integration skills. So I feel like Gritty, he likes U-Substitution, so we should like U-Substitution as well. I'm just trying to look over the front, these first few problems, and see if there's one where I wouldn't be able to pick U or I'd have a tough time, because sometimes that's the toughest part. And I'm looking to see problems like 3 and 4 when the function gets a little bit more complicated. And I don't want to solve 3 the full way, but I want to give you a helpful hint to start. And sometimes half the battle is just picking the right U. So think about it. See if you think you have maybe 3 choices for U. Maybe it's the whole numerator, sine of the ln of x. That's one option. Maybe it's just the ln of x part, and you might think it's that for some reason. That's another option. Could be the denominator. Sometimes it is, but just x, we've never really just picked x to be U. I'm thinking go for the innermost part. Go for just the ln that's on the inside of parentheses. You'll enjoy the rest of the problem, because if you take a derivative of ln, you have 1 over x. Solving this out, maybe multiplying x to the other side, x du equals dx, is going to take you pretty far in the question. This x is going to end up canceling with that x on the bottom. So don't forget to finish the problem. I just wanted to give you a head start. If ever you see one like number 4 where you've got a constant e to a power, let u equal the inside part of the function, just the power that e is raised to, not the whole e part of it. It just makes it a lot easier to see this as what power e is raised to. Keep going with that, right? We'll say du equals 5 dx, and dx equals du over 5. That should give you a good head start to sub back in and integrate number 4. 5 and 6 I kind of consider similar. I don't really know sometimes whether I should pick sine or cosine to be my u. One piece of advice in 5 and 6 is never bring the power with it. Either just make it sine or make it cosine, and use the function that you see raised to a power. Like here, the sine of x is to the 10th. That's a little bit more innermost, and the cosine isn't. My advice is, if you're going to try a function first, try the one that's being raised to the power and see what that gets you once you take a derivative. See if you can continue. Same thing here. The cosine is going to be raised to a power. So when you go to try number 6, let u equal the cosine of x because it's to the 5th. Okay, same thing with 7. Use the inside. Make u the innermost part of the function. Let u equal square root of x minus 1 and see how far that gets you. 8 is the toughest one on the front side. Maybe not the toughest, but like the most complicated looking. So I actually wanted to try to solve this with you. Think of what you would make u. We have just a constant up top, and we have x ln of x on the bottom. Remember, I took x off the table. We never let u equal x, and I don't think there's ever been a case where we've ever let u equal a constant. Let's let u equal ln x. Let's see this one through. Take it the whole way and see how far it goes. So we've seen this before. X times du equals dx, and we're going to use this and that to sub back in. All right, let's try it. Go back to the original. You've got integral of pi x times u, and then in for dx, we plug x du. Well, that should handle the x part, right? X is going to cancel. Get rid of that. And a constant never got us down. This is the integral of pi times 1 over u, if you want to separate it out. And 1 over u has a special rule. I know constants stay. 1 over u's antiderivative should be, is it just ln of u, or am I missing something? Absolute value of u. That is crucial. And then you can finish it, plug back in. This is just a weird looking answer. It's pi natural log, wait for it, of the natural log, because that's what we called u, plus c. So I think it's been a while since we've seen a natural log, of a natural log. Turn the page. I'll give you a few helpful hints on the other side too. Up top, just remember, these say no need for U-substitution. That's the hint. There's no substitution that needs to occur in 9, 10, and 11. Doesn't mean they're going to be easy. You'd have to manipulate. Like before I do 10, I'd probably want to rewrite it. Actually, this one can use the 1 over x rule. But I'd want to rewrite it algebraically so it'd be easier to take an integral. before I get started. And then the rest is up to you. You're just going to go to each term, and you'll be able to check it with a key too, but go to each term and see if you can integrate. Try that on 9, 10, and 11. Then I thought, why don't we look at least one word problem together? And I think the right one to try is probably number 12. It's the first one that's there. It says an environmentalist finds that a certain type of tree grows in such a way that its height after T years is, its height isn't this expression, its height's rate of change is this expression. So there's a huge giveaway that we're given a derivative in feet per year. If the tree was 2 feet tall when it was planted, are you thinking, I wonder why they gave us that info? Maybe to get C? How tall will it be in 27 years? So we need a height function, right? We need h of t. And we can use an integral to get that. We need the integral of 0.2, 2t plus 1 to the 2/3. And then we'll use a t here instead of an x. We're going to integrate with respect to t. I like this one for u-sub because I see an innermost part of that function with the parentheses there. So let's call that u. Let u equal the inside of those parentheses, 2t plus 1. And we'll derive. So derivative should be du dt, and we'll just call that 2. So du equals 2 dt, and dt equals du over 2. It's using t's here instead of x's, but pretty much the same process. Go back to the original, and let's sub in and hope for the best, right? We're going to use both of those things. So integrate 0.2, we'll just say u to the 2/3 power, and then for dt, we'll put du over 2, and this should equal h of t, the height of the tree. Now time to integrate. H of t equals, we'll say 0.2, 2/3 plus 1 is up at 5/3, so divided by 5/3 or times 3/5, u to the 5/3. And I forgot about that 1/2. Usually I swing those out to the front from the get-go. I will just put times 1/2 for that 2 that was at the bottom. And then a plus c will go in there because we're taking an indefinite integral. So all said and done, you can use a calculator on this part. H of t, if you do 0.2 times 3/5 times 1/2, we can call that 0.06. U to the 5/3 plus c. And we can sub back in now. Make it h of t equals 0.06 instead of u, 2t plus 1 to the 2/3, and that should be 5/3 plus c. Okay, tree was 2 feet tall when it was planted. That should be our initial condition to get us C. When 0 years had passed, the tree's height was 2. So we could plug in 2 for the height when t is 0. So 2 times 0 plus 1 to the 5/3. Okay, so we'll carefully get C here. Really, this whole thing comes out to be 0.06. So it's 2 minus 0.06 gives you 1.94 equals C. And that can get plugged back in here. Now we have a height function. We just got to answer the question. We got to find h of 27. So I'll leave you here. Here's your h of t. I'll just recopy it once more. 0.06, 2t plus 1 to the 5/3 plus 1.94. And now it'll be up to you to just carefully plug in 27, find h of 27, and you can round this solution. I said it was about almost 50 feet, 49.7 feet. Pretty tall tree. I wonder what type of tree that is, speaking of being outside here. But we've answered the question. Hopefully you didn't find the integral to be that crazy in that one. It was just kind of like piecing through the wording and trying to figure out what they wanted you to do. You have another good practice for a word problem here. You should find the process similar. And then just 2 ending problems, one that has e's in it, where I'd always recommend to make the innermost part of the function your u. And then the last one, 15. I was thinking if we could look at 15 too, that would make me feel a little better. We'll go let u equal. Okay. Think of what you want to do. This actually belongs on a challenge problem set. When we got into the packet for our practice problems to the most complicated ones, this looks tame, but it actually does take a few little tricks up our sleeve. So are we thinking make u x minus 7, the innermost part of that function? Because we could go du dx just equals the derivative of x, so just 1, and du ends up equaling dx. So here's your initial substitution. We need to integrate x times u to the 10th, instead of dx, I'm going to write du, and I'm in a little bit of a pickle because this is usually always the step where the x's magically go away for me. We got to come up with a remedy for this. So on one of the last days we practiced with U-sub, we actually use this little trick called back substitution. I want to show it to you here. So what we mean is, if we set u equal to x minus 7, shouldn't we be entitled to solve this whichever way we want to be more convenient for us, so we could actually solve it for x? We could add 7 to the other side and get u plus 7. It really helps here, because if you back substitute that back in, we have something that's not too bad in terms of u. It's u plus 7 times u to the 10th integrated with respect to u. And I would always get rid of parentheses if it's easy before I integrate, so you can distribute u to the 10th into both parts. So here's what we're going to do. U to the 11th plus 7u to the 10th integrated with respect to u. And now we work our magic, right? We're going to take an integral, so up a power, 1/12 u to the 12th plus 7 over 11 u to the 11th plus c. And we're almost set. The last part of this is just to plug back in for u, right? From what we originally had set u equal to. So we set it equal to x minus 7. 1/12 times x minus 7 to the 12th. Does that look okay? Plus 7/11, and then x minus 7 to the 11th. And we can call the last part plus c. This is indefinite. I am impressed. We are getting to some integrals that are not very easy. And so kudos for getting through something like number 15. Happy studying, happy reviewing, and we'll end it with a joke. And this one was sent in to me by one of you. And I think I'm going to get the wording wrong, but off the top of my head, it was, have you been to the new restaurant called Karma? They don't have a menu. You just get what's coming to you. It's either that or you get what you deserve. I forget the actual wording. All right, signing off. See you next time.